Section 2.7 is where we're going to introduce linear programming. Linear programming is the definition, process of finding the maximum or minimum values of a function for a region divided by a system of linear inequalities. First, we're going to graph the inequalities just like we did in the previous section. We're going to determine the coordinates of the vertices of that solution set that we found. We're going to use those to evaluate the function at each vertex, and then we're going to determine which one is the maximum and minimum. Let's take a look. So here's my first system. We're going to graph them, name the coordinates of the feasible region, and then find the maximum and minimum values. So for this first one, what it's saying is that you want to go to the x-axis. You're going to have a vertical line that goes through -2. That's going to be solid because there's an equal sign. Then I'm going to come over to the x equals 4. Actually, hold on a second. I think I have, I have a different paper I need to use. I apologize here. Let me try this again. So here we had it at -2 for my x-axis, and then I'm at +4 for my y-axis. Okay, they want you to be in between -2 and +4. That's what that notation is saying. So I'm going to shade everything in between those two vertical lines. Now I'm going to graph the next one. So I'm going to go to +2. I'm going to go up 1 over 1. I'm going to have a solid line because it has the equal sign. And then I'm shading less than that. So that means I'm shading everything below that line. Okay. Then on the next one, I'm going to -3. And I'm going down 1 over 2. I just changed it to its fraction form of 1/2. So that's why I'm going down 1 over 2. I'm doing a solid line again because I have, again, an equal sign. I want to shade everything greater than, so I'm shading everything above that line. So if you can see, I have my 3 colors starting here, going up to the next line, going back down this line, and then coming back across. So this would be my feasible region that it refers to. So you want to take your pencil and highlight where the vertices are. So that means your corners. So that's a vertex. This is a vertex. Down here you have another vertex, and then all the way up here. So you're going to write down the coordinates of those vertices so that we can find what the maximum and minimum are. So when I wrote down those coordinates, I found that I had -2, 0. I had 4, +6, 4, -5, and then -2, -2. So that's why they give you this function, because you're going to plug those in to then find which one gives you the maximum value or the minimum value. So when you plug it in, you would have -2, and then you put in your x, -2, +6, and then put in your 0. Then just type that in your calculator and you get 4. You're going to keep doing that with all 4 of them. So when I kept doing it, these were the values I got. So when you finish, you're going to find the maximum value. So my maximum is at 28. My minimum value is at -38. So what this can do is help you figure out if you can minimize or maximize a certain situation. So that's what we are going towards. Pause the video and try the next got it question. So in the got it question, after you graphed it, this is what it should have looked like. You should have gotten this region inside of there. So then you should have found, so because you had 2 horizontal lines between 1 and 5, you had your -3 down here for this line, and then your other one with a negative slope going this way. Then for your coordinates, you should have written down -1, 1, +1, 1, 2, 5, and then -2, 5. You're going to plug those into your function and then figure out which one was the maximum or minimum. So -8 times -1 plus 1 is going to give me 9. Negative 8 times 1 plus 1 is going to give me negative 7. Negative 8 times 2 plus 5 is going to give me negative 11. And then negative 8 times negative 2 plus 5 is going to give me positive 21. So my maximum, so my highest value is at 21. So that occurs here. And then my minimum value would be at negative 11 at that 0.25. Okay, so then on the next scenario, what you get to do is see where this is going. So the reason we practice this is because it gives you certain scenarios in word problems for you to figure out how to minimize or maximize a situation. So take a moment and read through this story problem. So we're going to minimize the amount, so that's important. Also, I underlined some other important information. We've got a 30 square foot plot. Each cucumber is utilizing this much of space with that much water. I also see that each lettuce is required to have this much space and then this much water. First thing I do is I find what we're trying to minimize or maximize. So I am going to minimize my water usage. So all of those numbers that required water, that's going to be pulled for my function. So I went ahead and wrote my function. So I'm using C for cucumbers and L for lettuce. So it requires 25 gallons for my cucumbers and 17 for my lettuce. So this is going to be my function that I'm going to utilize to help figure out my minimum for my water usage. Okay, so then I know that I can cross those numbers off because I am no longer going to use those when I write my equations. Next, it says we need to grow at least 4 of each type. So that means that I would need cucumbers to be greater than or equal to 4 and my lettuce to be greater than or equal to 4. I also know that I can have at least 16 plants in total. So if I add the two together, it can be greater than or equal to 16. The last thing that I have not utilized then is my total square footage. So my total, remember, is going to go at the end. Then to get that square footage, I've got to use my other square feet labels. So that's why I did 2.25 for my cucumber. And then I did 1.5 for my lettuce. So now what you're going to do is the function over here, you're not going to use it all. We're going to graph these just like we did on the previous. So I did C as X, and I did lettuce as your Y. So I put 4 on my cucumbers, 4 on my Ys, and I'm going greater than both of those. So that means that I need to be in this region, in this direction. Then I had to graph this function. So what I ended up doing is putting both of them at 16. So I did x-intercept and y-intercept at 16 and just made my slope stay at 1. If I'm going to be greater than that line, that means that I am going above that line right there. Then for the very last one, I went ahead and put it into slope-intercept. So I solved it for L. If you want to swap it out and make it X and Y, that's fine. So I made my Y-intercepts clear up here at 20. And then I went down 3 and over 2 because that's my fraction form of 1.5. So I went down 3 over 2 and I just kept going until I was all the way through to my x-axis. And I have to be less than that line, so that means I'm going down this way. Then I'm trying to find where all of my colors are intersecting, and I can see this little triangle area right here. So I'm going to find my vertices just like we practiced before. So that's going to be these 3 over here. And then I'm going to put them into my function like we practiced on the previous side. So I had 412, that got me 304. 414, that got me 338, and 88. Remember that we want to minimize, so this is an important word. So the one that is the smallest, the 304, is going to minimize my water usage. So I would want to do 4 cucumber plants and 12 lettuce plants. Okay, so that kind of puts in perspective of what you're doing to give you an idea of what linear programming can be utilized for. Pause the video and see if you can try the last got it question. So on the last got it question, so I went ahead and found my function. So I'm maximizing profit. So all of my money values for profit is what's going to go in my function. So the $12 per plate, so that's my PL. And my $25 for pots, that's my PO, that's my function. So I don't need to use those numbers for up here. So then I started to make sense over here. So Juan cannot carry more than 50 pounds, so I have to be less than or equal to 50. All of my pounds have to go in this same inequality. So 2 pounds for a pot, 1 pound for a plate. So that's how I knew those numbers were going to line up. Then it said he can make at most 5 plates a day. Well, we're doing it for 8 days. So that means I could make anywhere from 0 to 40 because 5 times 8 would be 40. And then over here for 3 pots a day, that means I could make anywhere between 0 and 24 in 8 days. So I came over and I graphed them. So I want to be between 0 and 24. So that means I'm using this region over here. So I was going to the right, this direction this way. Then I was going below my 40. So that means I'm going there. And then I went ahead and changed this into slope-intercept form. So I had y less than or equal to negative 2x plus 50. So that means I extended my graph all the way up here to 50, and I went by 2's. And so I just went down 2 and over 1 for all of these until I was all the way down here. And then I had to be less than that. So that means that I would be using this chunk over here. So my region stopped at this horizontal line, stopped at my 0 values, went back this way, and then it's really hard to tell, but it went right to here. So it was all of this section inside of here. So I had 5 points, 0, 0, 40, or I guess I went backwards. Yeah, 24, 0, 24, 2. Then I had 5, 40, and then 0, 40. Now, if you put your variables on the other axes, that just means you'd have the same numbers, but they'd be flipped, and it still works out the same. So it's okay if you had the flips of these. So then when I plugged it into my function to figure out which one would maximize my profit, the one with the largest was 624. So that means I want to make 24 pots, and I want to make 2 plates to maximize my profit. These questions are not easy, especially when your graphs are not big enough, because you have to be absolutely accurate in order for you to find those correct vertices. So just be careful on how you're setting up your graph so that you can see where those vertices are.